All right, welcome back, everyone. We're going to continue our discussion of Wood and Plastics Division 6. This is part 2 of our 4-part series. In particular, what we're going to be looking at in this session is looking at lumber and engineered wood products. So let's get after it. So let's start with the manufacturing process of lumber. Of course, it's coming from trees, right? And we start off with like you know what a log looks like, or the trunk of the tree. There's two different ways we can divide this up into our structural lumber, into our lumber pieces. One is called plain sawn, and the other one is called quarter sawn. And you can really see the difference on how the saw would go through and cut these pieces. For the plain sawn, I'd have all these individual rectangles. Versus the quarter sawn, my rectangles are going out radially in that direction. There's advantages to disadvantages, the advantages and disadvantages of both, which we'll discuss in just a minute. But if you are trying to figure out which one you have and you are looking at the end of your lumber, that's what you would see for your end grain, right? So if you start to see these concentric rings that are curved, then it is plain sawn, versus these parallel lines would be quarter sawn. So let's take a look at some advantages and disadvantages. Looking at plain sawn lumber, this is the less expensive way to produce your wood members. And if you think about the shrinking and swelling, what we said last time was that the wood tends to swell the most in our longitudinal direction, which would be this way, and less in our radial direction. So what does that mean? Well, if I look at this being my board, it means that when we talk about shrink and swelling, I have most of the shrinking and swelling is coming within that width direction, right? Getting wider and smaller, and less in the thickness. And that's all just based on the way the cuts are, right? An advantage to this is if we look at the knots, they don't affect the looks of the integrity as much, at least not as much as spike knots, and their shake and pitch pockets affect fewer of those pieces. Now looking at quarter sawn, this is a more expensive process, however it has many more advantages. It does shrink and swell less in the width and more in the thickness, and you should be able to see that, right? Because we said in the radial direction, the shrinking and swelling is less, but it'll have more in that direction. So kind of the opposite of what we had with our plain sawn. It tends to wear more evenly since the radial surface is more uniform. So we get an even wear. Holds paint better in some species. Works smoother for items to run patterns and profiles. Twists and cups less surface checks, splits over time, so you get a more stable dimensional lumber. It's not when it's seasoning and drying out, it's less likely to warp on you in different ways, right? So speaking of seasoning, that process where you are letting your moisture content acclimate, you want it to be as close as possible to its intended use, meaning if you're going to be in a dry environment, you want your moisture content to be very dry before you install this lumber, so you don't have these changes in size, or you don't have the shrinking and swelling. Everything will be exactly where it is. There is two different processes to seasoning. You could either air dry it or you can kiln dry it. Of course, kiln drying is a heating process. You're going to get a drier wood, 6 to 12% versus 12 to 15, and your seasoning will be listed on your wood itself. We'll talk more about what this means in a little bit, but you might already see that GRN, green, means wet, so we'll talk more about that. When we're measuring the amount of lumber needed, our measurement unit is a board foot, and a board foot is the amount of lumber in a 1 inch thick by 1 inch wide by 1 inch deep piece of lumber, right? So this would be 1 board foot. So if I have some other dimension, like say this looks like, what is this, a 2 inch by 9 inch by 4 feet, and I want to figure out how many board feet it would be in here, there's two ways you can calculate this. One way is to multiply your thickness in inches times your width in inches times your length in feet, and then divide that whole measurement by 12, or you can convert the whole thing to inches and divide by 144. because in essence your units would be inches, feet, feet, right? So this is inches, inches, feet, and this is inches, inches, inches. So whatever you have to do to get those units to work out. I think this top one is probably the easiest in most cases because unless you're dealing with like plywood, what we have typically is like a 2x4x8, or it's usually in inches by length in feet. So you usually know those ahead of time, right? So looking at an example for a 2x6x10, and I wanted to know how many board feet. I'm just multiplying 2 by 6, which is 12, times 10, which is 120. Divide that by 12, that gives me 10 board feet, and that's used for pricing to figure out your quantity of wood you need. You also could have converted it all to inches and divide by 144, you should get the exact same thing. One more example, what about a 2 by 8 by an 8-foot 5-inch? Well, what are you going to do with that 5-inch, right? So you either need to, same idea, you have 2 by 8, but then the 8-foot 5-inch, you need to convert the 5 inches into feet by dividing the 5 by 12, which gives you 0.417, so that's where that 8.417 comes from, then divided by 12. Or you could multiply the 8 times 12 and add 5. That gives you 101, right? So then we're all in inches. But whatever floats your boat, whatever way makes the most sense to you. So when we talk about classifying this softwood lumber, it's based on the American Softwood Lumber Standard PS20, and there's really 4 different classifications that we can look at. One is the use of this lumber. Is it going to be yard use, structural use? How is it manufactured? Is it rough sized versus dressed and surfaced? We just talked about how to cut it. How is it treated after we cut it, quarter sawn or plain sawn? What about the size, the nominal size of lumber? So 2 by 4, is a nominal size, or a 4 by 8. And then what about the grade? What's the quality of the wood? So those are the 4 things. We're going to look at each one individually, starting with the use. With the use, we have these 3 different uses. If it's yard lumber, then we have it's intended for ordinary construction or general building purposes, versus structural lumber. Then we're saying something that is usually something a little larger in size, and we are concerned with the structural capacity of the lumber, right? So we need the strength of the lumber. We have to know the strength of the lumber. And the last type of use would be factory or shop. So this is lumber that we're going to further use in the manufacturing process, not structurally, like the structural components of a building, but if we're constructing windows, doors, or trim or anything like that, what it is it's you're taking the wood products and you're milling them down in some way to fit your purpose. The next class we can look at is the manufacturer classification. Basically, when we cut a piece of lumber, we call that rough lumber, meaning it's not surfaced anyway. If we're cutting, say, a 2 by 4, it's 2 inches by 4 inches, cut straight out of our logs, and nothing is done with it, right? Versus if we are going to actually smooth it down and resurface it to a uniform size, that's called a dressed and surfaced lumber. Now, when we talk about that, there are different types to surface our lumber. We could have an S1S. What that means is it's surfaced on one side. So we have some pictures over here. Rough sawn is our straight out of the tree, just cut to size. S1S means like just the top would be surfaced, versus an S2S means both the top and the bottom would be surfaced. S1E is the edge. One of these edges is surfaced. Just one edge. S2E, 2 edges are surfaced. And S4S, all 4 sides are surfaced, dressed and surfaced. So why do we care? What does that mean? Well, what's its intended use, right? Does it matter if the bottom is an unfinished surface but the top is finished? Maybe you're only going to see the top. Maybe it's a cabinet where you're going to see both the inside and outside, and both are going to be stained or something. Or maybe one's going to be painted and it doesn't matter as much. So these type of uses could determine on how it's going to be manufactured. The third type is size, and when we talk about size, we start off with a nominal size, and the nominal size is different than the actual size. Nominal meaning the name, like here, what I have shown is a 2x4. So if we start off with a 2x4, we're naming it a 2x4, but then actually when we dress it and surface it, we're going to lose material. So it's like running it through a plane, right? So we're removing material in order to get the nice smooth surface uniform across the entire length of the board. And a 2x4, after we do this process, actually ends up being 1.5 by 3.5. Now there's three classes, general larger classes that we can talk about with these sizing. We have dimensional lumber, which are like your 2x4s, 2x6s, 2x8s, versus timbers are much larger, 4x8s, 4x10s, 6x10s, big, large structural members, versus common boards. Those are the much smaller boards, like a 1x4, at least skinnier in the one direction, right? So common versus dimensional versus timber. Now, this does show the nominal versus actual. Like I said, a 2x4 would be reduced in size down to 1.5 by 3.5 due to this dressing and surfacing process, right? And basically, you can take off this 1/2 inch from any of these dimensions. So a 2x6 would be 1.5 by 5.5 until you get up to these larger dimensions like 8. Once you get up to 8, you're going to remove 3/4 of an inch. So I see that the 8 dropped down to 7.25. The 2, once again, it's smaller. We're just removing 1/2, so we end up with 1.5. And this is true and until you get to these smaller boards, like a 1-inch board, it's going to be removing 1/4. So a 1 removes 1/4 during this dressing and surfacing process. And here's a little table over here that goes over that. If my nominal thickness is 1 inch, I'm going to lose 1/4 inch during that resurfacing process. If it's 2 to 6 inches, I lose 1/2 inch, and if it's 8 to 12 inches, I lose 3/4 of an inch. So you should be able to follow that through that table. So the last way we're going to classify our wood is based on the grade of the wood. And there's three ways we're going to look at that grade of the wood. One is the appearance. How good does it look, and how well will it take up a finish or a paint? Versus structurally graded, how strong is it? There's two ways we can check out our structurally graded. One is a visual inspection. The other one is machine rated, and we can see visually inspected. We're going to label them as a 1, 2, 3 construction standard, things like that, like select. So we'll go through those in just a second, but let's start with our appearance graded. So we're not relying on these members to have any structural characteristics, or at least we're not grading them based on the structural characteristics, just how they appear, their appearance, their aesthetics, their ability to absorb paint, stain. And I can see that for my grade I have either select, finish, or common, and the quality is going down as I move down this column, right? So select would be the top, then finish, common would be the lower quality grade as far as structural appearance. Then I'm also moving this way for quality, meaning select A would be my best of the best, and then select B, and then C, and then D. There's a little note over here, A and B left to natural finish, meaning that they're a good enough quality where they don't need to be painted or stained. C and D would be. And then for the finish, we have superior, prime, or E, following with our notation. Once again, quality is moving down as we move from left to right. And lastly, we have common, 1, 2, 3, 4, and at the very bottom we have 5. So our other one is stress graded. Once again, this is a visual inspection, and we're talking about our strength for structural uses, and moving from top to bottom, our select structural is our highest quality, highest strength. There's not a lot of knots or twists or anything like that, right? And then I move down to a number 1, and then a number 2, and a number 3. Below number 3, a stud, a common stud used in these load-bearing walls, versus a construction, more of a general purpose. Standard and utility is your very low-end quality as far as the structural integrity of your wood. So why do we care? We showed this slide last time where we have these different grades from the structural, number 1s, 2s, 3s, studs, construction, utility, And what we see is we have an overall rating. How strong are they in bending? And there's a huge difference from 1500 down to 275 psi, right? Same thing with the tension capacity of these things, right? So, and the modulus elasticity, so we would get much more bending as we go down. So that's what we really care about. If these were engineered, or as these are being engineered, we need to know these values, because the engineer will base it based on a assumed modulus elasticity or an allowable bending stress. And those things need to be acknowledged when we actually construct our structure out of wood. Otherwise we would have deflections that are too big, or could even actually have a failure. So these types of characteristics are marked on our wood. We have grade marks that'll tell us exactly this type of stuff. So like this you'd see this stamped on the end or on the face of a board, and there's different numbers on here. There's a mill identification number. There's a, which grading authority, who determined this quality of wood, what is its general purpose or its grade, such as stand, meaning standard. What about how it was dried or seasoned? We have S dry. S dry means that we have less than 19% moisture content. And we could have KD, which is kiln dried, versus S dried. We have S green. So green has a greater moisture content, greater than 19%. And you can see if it were kiln dried, we would have much less moisture, as we talked about before. What kind of tree species is it? Is it a Douglas fir, spruce, pine, fir, hemlock, southern pine, so on and so forth, right? So we got a lot of information from this stamp. So here's some more examples of the stamps. We have this WCLB, that's a West Coast Lumber Inspection. They're the ones who did the inspection on this. They graded this as a number 2. We talked about number 2 and the quality of a number 2. It's a Douglas fir. It was dried, not kiln dried, but air dried, and it came from mill number 10, right? And I'm not going to go through each one of these. You could go through these if you want. Western Wood Products and Southern Pine Inspection Bureau and Redwood Inspection Service, and you can see all the different numbers in number 3 and anything else. So let's see, moisture content of 15%. That's a maximum moisture content. Versus down here we have an S green, which would be that's a high moisture content, over 19%, mill 50. You get a lot of information when you look at them, but most of it is pretty self-explanatory once you see a couple of these. So like I said, those were all visually inspected. The other way that we can rate these is by using a machine to do the inspection. And if it is machine rated, it needs to be in part of the stamp. So this will say machine rated, right? And if it's machine rated, we'll have more information. We will have a bending stress. Like for this one here, it says machine rated 2100 FB. Remember, that's a bending stress. We also have 1.8 E. What that means is we have a modulus of elasticity of 1,800,000 in pounds per square inch, right? So we have these values, so we would know the exact strength, versus if they were just visually inspected, we wouldn't have those values. Instead, we're doing more of a general category type thing. So let's move on to engineered wood products in particular, making plywood or other types of panels. What is plywood? Plywood is a set of veneers. So a veneer is this little thin sheet of wood. It does have a direction to it. So I can see for this wood, this direction is that the grain is going that way, right? And the way this plywood works is we have a strong direction and a weak direction. And I think we mentioned this a little bit about the strong direction before. So in this case, our strong direction, meaning if I were to support this veneer on those two sides and push down, that's its strong direction. If instead I were to try and put it the other way, meaning I were to put a support here and over here and push down in the middle, the whole thing would bow a lot, right? Which means it's its weak direction. So all these veneers have a strong and weak direction to them. And what we do with plywood is we alternate them by 90 degrees in order to gain that strength, right? So this one is strong in this direction, the layer below is strong in the opposite direction, and then the layer below that is strong in that direction, the layer below that is strong in that direction. And that does two things for us. One is it gives us that strength in two directions, but the other thing it does is we talked about the swelling and shrinkage of wood, and we said along this long direction, along this long direction, it doesn't shrink very much. It does shrink and grow and swell in the other direction, right? So, but if we bind these together, then what you're doing is you are basically taking the fact that one layer doesn't want to expand in one way, the other layer doesn't want to expand in the other, and it makes it more uniform. It doesn't want to grow in either direction. The plywood is constructed in an odd number of piles, meaning it's going to be a 3-ply, 5-ply, 7-ply. And what that means is you'll end up with an overall strength of the plywood that's stronger in one direction than the other direction. And that's always your top and your bottom grain, right? So your top and bottom grain will be in the same direction. So for instance, in this one, this wouldn't be a whole sheet of plywood, right? Because there has to be another grain at the bottom or another veneer at the bottom that has all the grains going in the same direction. So we know which way the strong direction is on that plywood. Plywood has a lot of uses: walls, roof, sheathing, subflooring, and 4x8 is the most common size. And like I said, you can see it has a strong direction. So if I were placing plywood across these floor joists, I'm going to always put it with this 8-foot direction going this way, that is perpendicular to those joists. That's its strong direction, right? So all my grain is pointed in that longer direction. You can see plywood is regulated by the Engineering Wood Association and governed by standard PS1. So that's when you're going to determine your strength characteristics and your rating system, which we'll talk about in a little bit. We classify our plywood by the grade of veneers. You know, where there's multiple veneers piled up on top of each other, what is the grade of each one? And the bond type, how are they glued together, these different veneers. So starting with the grades of veneers, we have an A, B, C, D type classification, and it's really based on the knots. So you see no knots in this one. In B, you might have a knot up to 1-inch diameter. C, you're having a 1.5-inch diameter, not holes, so now you could actually have a hole all the way through that veneer of 1 inch across. D is your lower grade plywood. Any number of knot holes, diameters up to 2.5 inches, as you can see. There's also the number can be an issue too, right? So even if you had smaller knot holes or smaller knots, but you have a bunch of them, you'd be downgraded in your quality of veneer. As far as the bonding part of the classification system, we could have exposure 1, which is basically like during the construction process, it might be exposed to some weather, but then it'll be covered up. It's not going to be exterior for too long, right? Veneers have to be this grade D or better. We talked about D, so D is really this lower level stuff. And previously interior with exterior glue, which makes sense. It's not going to be used in an exterior application. However, the glue is strong enough to handle a little bit of exposure to the environment. Versus exterior would be used in more of a permanent outdoor exposed to the element. And then I need a higher grade veneer, C or better. So when we talk about these plywoods, we have the grade. So we could have an AA, AB, AD, AA, AC, BC, or marine. And what that is referring to is the face grade of our plywood and also those inner plies and our back ply, right? So so something like an AA interior has like A on the face, an A on the back, and then a D on the interior, so you don't have any knots on your front or your back. Both sides, you want that if both sides have to look really good. So this is what it's saying, like an interior cabinet, furniture, places where both sides are visible, we'd want this A quality plywood on those surfaces. If we have an AB, almost the same, but now we have a lower quality backside. This could also be used in cabinets and things, but you'd be painting probably the B side, where A, you could do a stain or something like that. Versus an AD, if you had an A on the face that's visible, D, you wouldn't want to be visible at all. It might be the underside of a cabinet or something like that. And if we have an ACA, now this is just like the ADA, but if you look at our interior plies are now a higher quality. So what that means is now we have a greater strength as well as a better appearance on both the two sides. AC, same idea, but we have C for one side is not visible. B, C, C. Then you're getting really rough here. So we're talking about B quality on one side and even a lower quality on C. Interior piles will be C. My experience when I was a kid was building half pipes for I used to do the BMX thing, and we always bought BC because it was the cheapest stuff out there. But I can tell you it was kind of rough to work with because there were so many knots, and when we're bending it to transitions, it would tend to crack right on the knots most times. But little aside. We also have marine applications, so faces either A or B. So this is pretty high quality stuff as well, right? So as I said earlier, we're going to be running our plywood in this long direction, and the question would be, how far can the plywood span between any adjacent supports? And of course, this would be different for roof or subflooring because you have different loading type scenarios, right? Typically, you have a higher total load. We talked about dead load and live load and all your various loads in your flooring than you would on your roof. And many times this span will be, the allowable span will be rated right on the plywood. And we have something like this where it says 32 divided by 16 for the sheathing. In that left-hand number, this 32 is the maximum recommended spacing when supports are used as roof sheathing with a long dimension across 3 or more supports. And then the right-hand number, this little 16, would be for subflooring. Same idea, across 3 or more supports. Now, this 3 or more supports has to do with the strength of our boards. Because if I just had a single span, we talked about single span and multi-span before, but as a review, if I have a single span, it's not nearly as strong. I'd get way more deflection than if I had multiple spans, right? Like at least a 2 span. And so these ratings are for that, and what we're saying is 32 inches would be, like the distance between each one of these would be 32 inches. And by the way, these numbers should always evenly divide. So, because what you really need is you need a 4x8 sheet will break evenly on either your roof rafters or your flooring joists, or whatever it might be. So because these are 96 inches, they should be multiples of 96. So I see 32 goes into 96 evenly 3 times, meaning I'd have 3 spaces, or 4. It would touch on 4 of those joists. 16 goes in there as well. 12 would be a really tight spacing. One that a lot of people aren't as familiar with, but I used a lot, was 19.2 inches. That actually evenly goes into 8 feet as well, 96. And the reason that becomes such a good measurement when I was doing concrete work is because it's the span. It was 24 was just too far of a span. Our plywood could not span a full 24 inches. And if we go down to our next one, it would be 16 inches. Well, 16 inches means I have many more members, right? Well, what if I did in between those two? That's 19.2. So here's a piece of trivia for you if you have a decent tape measure. All right, so what I have is a basic tape measure, and if I scroll it out to 19.2, I can see that there's a little triangle right there showing me that's where my spacing would be. Should be another one, 38.4. I can see another little triangle right there. And that'll keep going all the way through your 8 feet so you get your spacing. So 19.2 is one of those that not as many people are familiar with, but a little trivia for you. Next time you get a tape measure, ask someone else what that little triangle is for at 19.2. Let's see, where are we? So moving on to some other engineering wood products. We have OSB. This is OSB down here, oriented strand board. It is also directional, meaning it has a strong direction in the same way that plywood does, where my strong direction is this longer, this 8-foot direction, right? So these strands are these little rectangular pieces of wood that are all glued together in different layers, right? But overall, the strands are in that direction. So We also have particle board. We can see particle board here, basically just a bunch of wood particles, almost like leftover, probably larger than sawdust, that is bound together with some kind of glue, adhesive, and then made into board. And you'll see a lot of this in like less expensive furniture. And we also have fiberboard, and fiberboard's the same idea. It's a high density, it's a higher density than particle board, usually called MDF, which is medium density fiberboard. So, but really these are, less expensive forms. It's a way that we can use leftover wood materials to recycle them into usable products, right? So that's what I have for this presentation. I hope you found that informative, and I'll talk to you all later. Thanks.